All right, everybody, welcome to Digital Systems 2. This is Lab 1, Part 2. We're going over steps 5 and 6. Now, in the image, they're using a 74LS107N. Nowhere have they said to switch over to this, so I went ahead and created the demo with this chip. Otherwise, they meant to use a 74LS76. So the 74LS107 is not a D flip-flop. Neither is the 74LS 76, right? So the 107 and 76 are neither, but you can convert them to operate as a D flip-flop. So what you do, if you want them to function as a D flip-flop, you connect the J inputs together. And the one condition is that the J and the K always have to be in opposite of each other. So that is the reason you see where's my mouse? The inverter there to ensure that J and K are always opposite. Then it'll run in the D flip-flop mode. Again, we could have done this with the 76, but on the image on step 5, they're using the 107, so I went ahead and just created this demo with that. What else? So also this device is also a negative edge trigger, just like the 76, meaning that it changes state on the high to low transition of the clock signal. Excuse me. So the key difference, again, from a standard JK truth table is that for the D flip-flop operation, K must always be opposite of the logic state. And what I've done here is I've already ran through the cycles. I put the outputs there, and so you can see the image of what to expect on the operation of this. Give me one second. Sorry. Like always, I'm going to go ahead and just kind of walk you through the um, wiring. So I'm going to zoom in a little bit, move these out of the way, move these out of the way. There we go. And I am still running. Okay, that's fine. I'm going to go ahead and just close that out so I'm going to close these out real quick so I can zoom in properly. Let's go through this whole field. Okay, so you can see the clock that we're running it into the function generator. Let me do that right there. That's a little bit better. So we're running the clock into the function generator. Notice that we have the digital input output pin 0. That is running the clear. And we are running the digital input output pin 1 into both the J and the K, but we're using an inverter to make sure that J and K are always opposite of each other. What else? That covers those. And then the outputs. We have pin 3, which is the Q output. That's going to be indicated by the reader on pin 8, and the Q naught, which is out of pin 2, and that'll be indicated by the indicator on the reader for pin 9. What I've done here is just I looked for the best image I could find. The spec sheet actually didn't have a very good image. It was the lettering was too small, so I found something that was a little bit bolder so you can see the pin out. Right, so the J and the K, pin 1 and 4, you can see that we have J here on pin 1 and the K here on pin 4. Q naught is on 2 and Q is on 3, so the same thing here. Q naught is on 2 and Q is on 3. What else are we missing? The clock is on pin 12. Pin 12 is over here, the clock pulse. Notice that it is also inverted in the footprint. Same thing over here. I'm sorry, on the symbol and then on the footprint that aligns with each other. So yeah, so we got the right chip right here. And I am running this right now. So yeah, again, I already went ahead and ran through the cycles. I've already filled this out so you can see this. And now I'm just going to demonstrate the whole thing for you. Okay. And let me open up my function generator. I'm going to turn this off, but I'm just going to show you the same thing. I went ahead and put this at 5 volts peak to peak, 2.5 volt offset, square wave, so I can get that square wave at 5 volts up and 0 down. Let me just go ahead and get rid of that out of the way since we don't need to see that anymore. Let's hide this. I'm just going to open up the reader and put that right down here. And, and my writer. Okay. Sorry, right there. And I'm just going to go through the truth table. You know what? I might just, oops, I hate when it does this. Right there. I'm actually, so you see how it's wired. I'm just going to go down here to the truth table and show you what's happening. Okay, so don't worry about this preset column. This is what makes me think that they intended this to be for the 74LS76, because that does have a pre and a clear. But again, the image was of the 107, and you notice the 107 doesn't have that preset. So I'm thinking they meant that. So here we go. We have the clear. When the clear is low, it doesn't matter what the clock is or the D input. We are just going to have a Q at 0 and a 1 at the Q naught. And this is a reset for the asynchronous operation. So let's go ahead and see what that looks like. I am running it. Ooh, please don't move on me. I don't know why it's doing that. I'm trying not to. I'll try to stay out of that. Okay, so let's go to our writer, and it says clear is 0. The clear is 0, if you can see that. And what we have is the Q naught. Pin 9, if you remember, is associated with Q naught. Pin 8 is associated with Q. So Q naught is high, and that is in accordance with what we see there on the truth table. Now the other condition is where we have the clear set to high. Now that's going to result in a no change. Again, so let's go ahead and move this to high, and notice that this won't change. I click on that. All right, give it a second just so you can verify this. It does take like a second or two for the change to happen here in the simulation. And you notice that there is no change. Okay, and the next condition is when the clear is high and D is low. Now, when we're saying D is low, we're saying that according to the 107, we're putting a low on the J input, right? And so let's go ahead and do that. And I just want to just show you one more time. Right, where is it? Right, so there's a J. The J is on DIO1. And remember that pin 4 for the K is always going to be the inverse of whatever that is. So we just want to set the digital input output pin 1 to high. Right, so let's do this, which is this one right there. And give it a second. Oh, I'm sorry. Yeah, I'm sorry. I jumped to the very bottom condition. That's okay. We'll continue with the recording. So what I just did is we've got the clear high and then we've got the D high, right? So I meant to do that. So the D is high, the clear is high, and we have the Q high and Q naught to 0. So remember, pin 8 is associated with the Q and pin 9 is Q naught. So this is high, there's a 1 there, and there's a 0 there. Now let's do the last condition. We'll just jump a little bit, going backwards. Keep the clear high. Now we're going to set D back down to 0, and we're going to notice that this is going to go ahead and flip. So we're going to just put this back down to 0. Clear stays high, and this should change. There it goes. And that's it. I want you to run through that and see how you can make a JK flip-flop. In this case, according to the image, they were using the 74LS107, but I'm pretty sure you can do the same thing with the 74LS76, but just to be consistent with the image that's being used. Okay, and that's it for this one. Thank you very much.